So here's part 2. And we're talking about rate laws, which are mathematical expressions that describe the rate of a chemical process or chemical reaction. And if we have a reaction that is given here in blue, lowercase a plus lowercase b plus lowercase c yields lowercase d. We're going to write the rate equation. This is for concentration changing over time. Rate equals K, A concentration to the X, B concentration to the Y, C concentration to the Z. And K is a constant. X, Y, and Z are called reaction orders. And we have to get those from experimental data. And there is something called the overall rate order or reaction order. And it's just whatever X plus Y plus Z would be. Again, if there's only one reactant, it would just be rate equals Ka to the X. If there's 2, it would be Ka to the X, B to the Y. And if there's 3, A to the X, B to the Y, C to the Z. If they have to be calculated for an experiment, you can't use your balanced equation for that. Any connection between X, Y, and Z and the coefficients is coincidental. So, I should have cleared this one. Let me do that now. There we go. So if we want to look at, here we've got 6 experiments with initial concentrations of ammonium ion and nitrite ion. And what I'd like you to notice is, I'm just going to use a couple at a time. Make this bigger. If I'm looking at 1 and 2, you will notice that when the NH4 concentration doubles, as this one stays the same, the NO2 concentration stays the same, that the rate doubles. So when the NH4 concentration doubles, the rate also doubles. Let's take a look at, how about 1 and 3? Oops. From 1 and 3, rate, or the concentration of H4 goes up by 4 times. This was no change. The rate, the concentration went up 4 times. The rate goes up by 4 times. So whatever happens to the NH4 concentration, the same thing is happening to the rate. And when it's 1-to-1 like that, then the rate order, or reaction order, is 1. So this is going to be something to the effect of NH4 plus to the first power. Your X in this case would be 1. All right, let's take a look at how the NO2 concentration changes. All right, so if I do 4 and 5, okay, again, no change here. The NO2 concentration is doubling. The rate is doubling. If we look at 4 and 6, the rate here, concentration is the same. Concentration here times 4. Rate changes by 4 times. So whatever's happening to the NO2 concentration, same thing is happening to the rate. So the reaction order, it's also first order. So we would write rate equals K, which is the rate constant, which we don't know. NH4 plus to the first, NO2 minus to the first. Okay. Well, I'm going to stop here so I don't run too long, and I will catch you in just a minute.